Introduction to blockchain. A blockchain is a decentralized digital ledger that securely stores records across a network of computers, ensuring transparency, immutability, and resistance to tampering. Data is stored in blocks, which are linked together chronologically to form a continuous chain. A blockchain is a distributed database or ledger shared across nodes within a computer network. Although blockchains are most commonly associated with cryptocurrency systems, where they securely and transparently track transactions, their applications extend far beyond digital currencies. Blockchains can be utilized in various industries to ensure data remains immutable, meaning it cannot be changed once recorded. Since a block cannot be altered, trust is only required at the point where data is initially entered by a user or program. This eliminates the need for intermediaries, like auditors or other third parties, reducing both costs and the potential for human error. Why is blockchain important? Blockchain is a groundbreaking technology that significantly reduces security risks, combats fraud, and promotes transparency in a scalable manner. Initially popularized through its connection with cryptocurrencies and NFTs, blockchain has since transformed into a versatile management solution across various global industries. Today, blockchain is being used to ensure transparency in the food supply chain, protect healthcare data, innovate the gaming sector, and revolutionize how we manage data and ownership on a large scale. How blockchains work. Blockchain technology is a revolutionary system that enables secure, transparent, and decentralized record keeping. At its core, blockchain is a distributed ledger that stores data across a network of computers, ensuring that no single entity has control over the entire system. Originally developed as the underlying technology for cryptocurrencies like Bitcoin, blockchain has since expanded to various industries, including finance, supply chain, healthcare, and more. Its unique structure and cryptographic principles make it highly resistant to tampering, fostering trust and efficiency in digital transactions. To understand how blockchain works, it's essential to explore its key components, such as blocks, chains, decentralization, and consensus mechanisms. Here is a breakdown of how it works. 1. Transaction initiation. A user initiates a transaction, which can involve sending cryptocurrencies, transferring assets, or other types of data. Exchanges. 2. Transaction verification. The transaction is broadcast to a network of computers, called nodes. These nodes validate the transaction based on pre-established rules, such as verifying that the sender has enough balance for a cryptocurrency transaction. 3. Block creation. Once validated, the transaction is grouped with other transactions into a block. Each block contains a list of transactions and a unique identifier called a hash. 4. Proof of work/consensus mechanism. In many blockchains, a consensus mechanism is used to ensure that all nodes agree on the validity of the block. For example, in Bitcoin's proof-of-work system, miners, special nodes, solve complex mathematical puzzles to add the block to the chain. 5. Block addition to the chain. After the block is validated and confirmed, it is added to the existing blockchain. Each block contains a reference to the previous block, its hash, making it impossible to alter past blocks without changing the entire chain, which is computationally infeasible. 6. Decentralization and security. The blockchain is maintained by multiple copies on different nodes across the network, making it decentralized. This ensures security, as altering the blockchain requires control over a majority of nodes, which is practically very difficult to achieve. 7. Immutability. Once a block is added to the blockchain, it is immutable, meaning it cannot be changed or deleted. This ensures the integrity of the data recorded on the blockchain. This decentralized, transparent, and secure structure makes blockchain technology useful not just for cryptocurrencies like Bitcoin, but for a variety of applications, including supply chain management, voting systems, and contract automation through smart contracts. While it initially gained prominence through cryptocurrencies, its applications now extend far beyond, offering innovative solutions for industries seeking secure and efficient data management. As blockchain continues to evolve, its potential to transform traditional systems and processes remains vast, paving the way for a more decentralized and transparent future. Blockchain decentralization. Blockchain technology is fundamentally built on the principle of decentralization, which transforms how data is stored and verified. Rather than relying on a central server or authority to manage the data, a blockchain distributes the data across multiple network nodes, which are essentially computers or devices that run the blockchain software. These nodes can be spread out over different geographic locations, creating a decentralized system that ensures transparency, security, and redundancy. The key benefit of this decentralization is that it prevents any single point of failure. For instance, if one node experiences a malfunction or a malicious actor attempts to alter a piece of data on it, the integrity of the information remains intact. The other nodes in the network can detect the discrepancy by comparing the blockchain's cryptographic signatures, known as block hashes. This process ensures that data cannot be tampered easily because the information on the blockchain is verified by the consensus of multiple, independent parties. A blockchain's decentralized nature also has profound implications for data immutability. Once a piece of data such as a transaction has been recorded on the blockchain, it becomes practically irreversible. This is due to the encrypted proof of work or consensus mechanisms that validate and secure each new block added to the chain. If someone attempts to modify a record on one node, the inconsistency would quickly be spotted by the other nodes, and the proposed change would be rejected. This makes blockchain an ideal technology for applications where data integrity and accountability are crucial. While blockchain is commonly associated with transaction histories, particularly in cryptocurrencies like Bitcoin, its use extends far beyond simple financial records. Blockchain can also store a wide range of information, such as legal contracts, state identifications, medical records, intellectual property rights, and even a company's inventory. However, most blockchains do not directly store these types of data due to storage limitations. Instead, sensitive or large-scale data is usually processed through a hashing algorithm, which generates a unique fingerprint or token that represents the original data. This token is then stored on the blockchain, ensuring that the data remains secure, traceable, and verifiable without burdening the blockchain with large amounts of raw information. Furthermore, the decentralized nature of blockchain plays a critical role in the development of private blockchains. In private blockchains, only authorized participants have the ability to access, validate, or update the data stored on the network. Despite being permissioned, the decentralized architecture ensures that trust and security are maintained across all transactions. This makes private blockchains an attractive solution for industries such as finance, healthcare, and supply chain management, where data integrity and security are of utmost importance. To conclude this video, blockchain's decentralization offers numerous advantages over traditional centralized systems. It ensures data redundancy, prevents tampering, and fosters trust between parties without the need for intermediaries. With its ability to store a diverse range of data types securely and immutably, blockchain has the potential to revolutionize industries beyond just cryptocurrency, offering transparent, secure, and efficient solutions across various sectors. Types of blockchain. Blockchain technology is not a one-size-fits-all solution, it comes in various forms, each designed to meet specific needs and use cases. Depending on the level of access, control, and participation, blockchains can be categorized into different types. These variations determine who can participate in the network, validate transactions, and access the data stored on the blockchain. It is crucial for organizations and individuals looking to use this technology to understand each type, as it offers unique advantages and trade-offs in terms of transparency, security, and scalability. The most common types of blockchains are: 1. Public blockchain. Public blockchains are decentralized. Permissionless networks where anyone can participate as a node. Validate transactions. And access the ledger. These blockchains are open to the public and have no central authority. 2. Private blockchain. Private blockchains are permission networks where only selected entities can participate. These blockchains are usually governed by a single organization or a consortium of organizations. And access is restricted. 3. Hybrid blockchain. Hybrid blockchains combine features of both public and private blockchains. In a hybrid system, some data is kept private, while other data is made public. Organizations have control over the private aspects, but certain parts of the blockchain are accessible to the public. 4. Consortium blockchain. Consortium blockchains, also known as federated blockchains, are partially decentralized. Permission networks managed by a group of organizations or entities rather than a single party. Multiple participants govern the network and validate transactions. 5. Sidechains. Sidechains are separate blockchains that are attached to a main blockchain, often referred to as the parent chain. They allow assets or data to be transferred between chains without affecting the security of the parent chain. 6. Blockchain as a Service, BaaS. Blockchain as a Service, BaaS, is a cloud-based service that allows businesses to build and host their own blockchain applications without managing the infrastructure themselves. BaaS is often provided by third-party companies such as cloud service providers. 7. Directed acyclic graph, DAG. Although not a traditional blockchain, directed acyclic graphs, DAGs, are sometimes referred to as blockchain-like structures. DAG is a graph structure where transactions or data points are arranged in a way that allows faster processing times and higher scalability than traditional blockchains. Each type of blockchain is designed to meet specific needs, depending on the level of decentralization, transparency, security, and control required by the users or organizations involved. If you have enjoyed this video, don't forget to visit our online educational platform at www.eduslides.com by registering for free courses. Guess what? You can as well earn a certificate of completion after completing your course, and you don't have to pay to register. Why not subscribe to our YouTube channel to get more videos by clicking the subscribe button below?